अरे आपल्या प्लॅन किती नाही चॅनलला क्या हाल चाल। अरे अपने पास यूज करेंगे आप ये अभी तो एक फिलहाल इसका यूज कर रहा सिम का या तो ये क्लास वो ईयरफोन्स थे ना ईयरफोन्स चाहिए इसका हाँ सिम का मैंने यूज कर ए नीचे रुकने का बड्स तेरे ने ठीक है मेरे पास ओके का वो चाहिए तो भी चाहिए बस मिनट नहीं मैं अभी Hello, am I audible? Hello. Hello. Hello, guys. Only super pro. Hello, Lokesh. I also am I audible? Music premium. If I'm audible, once raise your hand. One second, I'll join with another laptop. Hello, I'm audible, guys. Hello, Lokesh, Akash. Let's turn on your mic. Yeah, you are audible, sir. Okay. Let's wait for 2 to 3 minutes. Let everyone join.
Hello guys, how are you all? Hello, am I audible guys?
Sure, you are audible.
Okay, so today Bilal sir is on some personal work, he's on leave. So today I'll be taking the class. So once any one of you once turn on your mic and can you tell me like can you brief me about everything what you have done things till now?
But till now, sir, explained about the basic concepts like a theory concepts like
Mm,
how do we use GitHub and what is use of Git and render. Later, he have explained about the NLP concept like tokenization and
okay, tokenization and vectorization, right?
vector. Yes, sir.
Taught us about
We
the
didn't complete about
smart
vectorization.
NLP.
Just we know the basic about vectorization, sir. He said that today we'll discuss more about vectorization.
Okay guys, so once one second, let me share the screen.
ऑफ कर दिया ऑफ कर
So guys, once you learned about tokenization, vectorization, and all those things. Like, so let's first I'll let you know about life cycle of NLP. Just let's clear the basics also. Once revise the topics. So once anyone of you once tell me what is NLP? What defines NLP? Anam, Lokesh, anyone?
NLP language processing, where we analyze, generate, and understand the human language.
Okay, human language. We understand the human language. By what methods we understand the human language? So
Like
because
generate.
naturally, computers doesn't understand natural language, right? So how are we doing that?
Vectorizing?
What?
Are we vectorizing?
Okay, vectorizing. What is vectorizing?
It includes one hot encoding.
One hot click encoding. So first, let me tell you, vectorizing is like converting the text into numbers formats, numbers or any type of vectors. So why are we converting this into vectors? As you said, one hot encoding. It is one type of vectorization technique. That's it. There are many types. One not encoding, CBOW, like bag of words, TF-IDF, many are there. I'll explain you everything. So first we need to understand the purpose. Why are we converting? Why are we vectorizing the text? Can you tell me guys any reason? Why are we converting into numbers
In this, we can store the data in the form of sets.
in the form of
Sets.
text? Okay. Any other answers? Anam, what do you think? Anam, Sahit,
To
Akash.
make faster, like
So
much
first of
faster.
okay. So guys, are you familiar with machine learning models? Any machine learning models? Linear regression and all those things.
Yes, sir.
You're familiar, right? Everyone. If anyone is not familiar, means just let me know, guys. It is important. Guys, Should I explain you?
Sir, we are familiar with the topics.
Like machine learning topics, right? Everyone I'm asking.
Yes, sir.
Okay. So as you know, in today's life, like we see chatbots. Chatbots. If we give some input in our human language, means it will give us response, right? So what it is internally doing, it is using some kind of models. Machine learning, it may be machine learning models, deep learning models, and any LLMs, anything, right? It's predicting the response. That's it. A simple thing is it is predicting the response. But what NLP does is normally these models doesn't understand text data, right? If we see some any linear regression model also, any machine learning models also, we have formulas, mathematical formulas, right? So does text implies in mathematical formulas? Can we use text in formulas? No, right? Guys, I need response. Hello.
Yes, sir.
So in machine learning models, we use mathematical formulas. In those formulas, we can't input our text data. So that's why we are vectorizing the text data. What is vectorizing? Means converting the text data into numerical values. Okay. There are many types of techniques to do that. First, let's understand the life cycle of NLP, why it's mainly used. So this is important topic. So first thing is text collection. So text collection means like collecting the text. So where do we find our like majority of the like natural language text? Any platforms anywhere, somewhere. I'll give you one example. Social media. In social media platforms like Twitter and all those things, we see like people do tweets, right? So from there we can get the text of some particular user. Suppose if you are having some product, any product you launched in market. So people talk about your product in they tweet about your product, they do some mention hashtags and all those things. So we collected those text data. With those text data, if we perform NLP and use some models, means can we predict the like performance of the product, right? Based on the
Yes,
user's
sir.
text, right? If it's a coming
Correct.
positive responses or negative responses, we can do that. That thing's only achievable through NLP. If somewhere there is text involved in the data, any data set or anything, then we must use NLP in there. Okay. So this is the first in NLP life cycle. This is the first technique, first method, you can say, first phase. So after text collection, we go through text cleaning process. Okay. So normally, when we after the collection of text, there is abundant amount of text, right? Like there are so much of text. But if we directly convert those text into numerical values, there will be like much more complex values, like many vectors it will be formed. So that much complex things our model can't treat well. It is not an optimized way. That's why we are doing text cleaning. Text cleaning means we'll clean the text. Whatever the unwanted text, unnecessary things, junk things, noise data is there, we will remove it. There are so many methods like regex we can use and many more things. Even inside this text cleaning also, we use stemming, limitize, stop words. You learned about stop words, right? Sir has explained you. Yes. Stop words removal. Yes, guys. Hello.
Yes, sir. We learned about stop words.
Okay. So stop words, what does it do? It removes like we remove unwanted text, right? Like is, a, the, and all those things. Because that doesn't contain that much any meaning in the text. So we do all these techniques in text cleaning. After the text cleaning, we get feature engineering. This is the core principle of NLP, feature extraction. Okay. This is the core principle of the NLP. Today we'll talk about this only. After featuring engineering, we'll get like model training. We'll choose our best model, which we send our numerical values after feature engineering, and then we'll do the predictions. Okay. So first understand about feature engineering. One second. Guys, sorry for the delay. So, okay, we are talking about feature engineering. Feature engineering is the concept of converting the text into numerical values, right? So yesterday you said like you have learned about one-hot encoding, right? So guys, once any one of you can tell me what is one-hot encoding? What are the things you learned yesterday?
Yes, so one hot encoding includes 1 and 0, where one element is hot and others are 0. So again, it converts into byte, then converts into the machine language.
Yes. Like it's 1000, like this type of data we'll get, right? So as of now, this is like a simplest thing, like simplest technique which people use, but it's not that much like good technique. Later on, we came with another technique which is known as bag of words. So here I am like giving one example. Suppose like, okay, he is good coder. He is bad coder. Yes, can you see the two sentences? Okay. So whenever in NLP we are dealing with text, each sentence is known as documents. This is document 1. This is document 2. Okay. Here we in each sentence we perform lemmatization, stop words and everything, right? So it will be in tokens format. E one token, is one token, good one token, coder one token. Okay. So bag of words. It is one of the like important technique which you must learn. Everyone will ask you if you go into interviews also. So how to perform bag of words? First, we'll take the unique words from the two documents. Suppose if I am having these two documents only, I will take unique words. Here, what are the unique words? Can you tell me? Anam, once tell
Good
me
and
what are
bad.
the good and bad and unique words in this two documents.
Coder.
Yes, coder. He and is also, right?
Oh, yeah.
He is good, coder, and bad. So from entire these two documents, I'm taking the unique words. Okay. Same thing here also. He is good, coder, bad. So wait 1 second, let me write it like this. Document by document, we'll do it. So this is document 1. This is document 2. So listen here carefully, guys. So in document 1, he is present. In
Yeah.
document 1, he is present or not?
Yes, it is
Yes, right?
present.
Then
Yeah,
we'll add 1. We get 1. In document 1, again, is present. Yes,
we
is
get
it present? We
one
get
value.
again 1. Yes, yes, madam. And good. Good is present also. We get 1. Coder is present. We get 1. This bad is present.
We get 0.
Yes, we get 0. And again, same thing in document 2. He is present. Is present. Good is not present. So we'll give the value as 0. And code is present and bad is present. So in bag of words, we count the frequency of the terms. So for document 1, this will be the vector, and document 2, this will be the vector. Once again. Okay. So document 1 vector we got 1 1 1 1 0, right? And document 2 we got 1 0 1 1 1. No, I guess. Yeah. 1 1 0 1 1. These are the two vectors we got for document 1. So once, can you tell me, guys, what are the drawbacks in this bag of words? Once, see carefully. For document 1 is good, coder is bad, coder. Okay, this is for he is good, coder, bad. Okay, once, see carefully. My handwriting is not that good in this iPad. Okay, here once, see this digits carefully. Here in document 1, it is assigning he as 1, right? And is as 1, good as 1, coder as 1, and bad is 0, right? These are the values it is giving to those text in the document, this vector, the single vector, it is giving these values, right? So now tell me one thing, which is more important in this both sentences? He is more important or good and bad is more important?
Good and bad.
Good and bad important, right? If I'm writing is coder, if I remove good from document 1 and if I remove bad from document 2, these are the sentences. Does it make any sense, guys? Both are similar only, right? Does it make any sense
Yeah.
if I remove good and bad?
No.
No, right?
No.
The same thing. I'm removing he. Is good coder, is bad coder. Now it's at least a little bit making sense, right? Is good coder, is bad coder. Why? Because we are using these words. In these documents, these words are important, right? Good and bad. That adds some semantic value to it, right? Yes. Here, good and bad is adding some kind of information in these two sentences. So, but see here in document 1 and document 2 vectors, it is giving one value to he and one value to good also. make some kind of problem, right? If I give same value to our machine learning models, then it will treat the both he word and good word in with same treatment. Like it doesn't give any importance where it should give, right? Our machine learning model should give some importance to the good word, right? Because if we want to do any some kind of semantic analysis like predictions, whether it's a positive sentence or like negative sentence, this one is a positive sentence and this one is a negative sentence, right? How we know that? Because of this good and bad word, right? So these words should give some kind of priority in it. It should give some kind of importance. But that thing is not being done by bag of words. If someone is asking what is the major disadvantages of bag of words, then you need to mention this. In bag of words, each word, each and every word is given same importance. Okay? Understood, guys? Guys, understood? Or should I tell again? Everyone? Sahit,
Clear. Clear.
Sahit, Akash Gupta,
Yes.
and Sahit, Satvik. Are you guys understanding? Or should I repeat? Guys, tell me fast. Okay, now let's move on. So, guys, once see carefully, and there is one more disadvantages in bag of words. Once try to find it. One thing is it doesn't give any importance. Okay,
No, doesn't have any meaning.
doesn't have any meaning. Yes. Okay.
Not in
Like
order.
okay, not in order also. Excellent. One more most important thing is there. One more thing. If you see carefully, you will get it.
Most values are 1.
Most values are then okay, it's fine. That's what we are doing here. That's why we are not giving any importance. We are treating same everything equally. We have already written. So guys, I'll tell you one example. He is he is taking Apple phone. Okay. And one more sentence is like he is taking apple fruit. Okay. So what are the major difference in this both sentences? Tell me.
Phone and the fruit.
Phone and fruits.
Okay, phone and the fruit. If I pass the both sentences in the bag of words, it will treat apple as same value, right? But in this case, here in sentence one, apple is one product, one phone. But in sentence two, an apple is a fruit, right? But our bag of words doesn't understand that.
Cannot understand a word, same word which can have multiple meanings.
Yes,
It may
exactly.
confuse according to the situation. It can't
Hmm.
analyze the situation. It directly predict the answer.
Hmm. So if you want to really know about the meaning of the word, how we can find out?
Sir, by checking the situation, sir, just like
Situation
taking
means
apple,
okay. In
uh,
this,
we
see
can
this
we can say
sentence.
like there one example like is playing with the bat. The bat may be an animal or a cricket bat, sir.
Okay. Here, see in this sentence, which made you think that this is an Apple phone, like Apple is a product? Which thing made you say that Apple is a product? Like which word?
The context.
The context. Like which word? What is the context here? Which word made you think that Apple is a mobile phone here? Here, see this
Taking.
sentence. Which word?
Taking.
Not
Taking
taking, Anam. Phone, right?
Yeah.
Phone, right? If you read the Apple phone means, then you understand, acha, this is an Apple phone, right? Here, if you see fruit, then you think, acha, apple is a fruit, right? By the words which are relative close to it, we can find out, but not in bag of words. So now listen here carefully. One more major drawback, which is contextual information. It doesn't provide you. So bag of words, it's mostly commonly used in initial phases for a little bit of small data set, small text, which doesn't have that much diversity of the text in it and all those things. So that's why we use bag of words. It came like very in old times, previous at starting model. So what are the drawbacks we are having in bag of words? Tell me. Three drawbacks, tell me.
It cannot
It treats each
analyze the
and every
situation.
as a, it gives each and every word the equal importance, and it doesn't have
Okay.
contextual information. I mean, it
Okay.
doesn't provide the correct information. It is not in
Hmm.
sequence.
Yes, exactly. If anyone is asking you what are the drawbacks of bag of words, you need to mention these three things. That's it. Okay. If like asking you how bag of words work means, then you can just show this he is good coder, he is bad coder example. Then you can show the drawbacks, like here good and bad, like he and good is having the same value, same importance we are giving. So that's that thing we can't give to our machine learning model. Okay. So to overcome this, new model is came. These are the vectorization techniques, guys. Okay. Here we are converting into numbers. Okay. Don't confuse it. Okay. At last, we want the numbers only. These are techniques. So one more technique, which is TF-IDF. Okay, this is like famous technique. Majority of the people use this technique also only. One more technique is there. I'll tell you later. So TF-IDF, term frequency and index document frequency, inverse document frequency actually. Term frequency and inverse document frequency. Okay, this is like most important vectorization technique you need to learn. Okay, listen carefully, guys. Here we'll take the same example only. Is good coder, is bad coder. Okay, 1 second, guys. Once again, current time. Okay, sorry for that, guys. Actually, there is no current in our office. So charging is also not there that much. Okay, we'll see. We'll wait for some time. Okay, term frequency and inverse document frequency. So you're I'm audible, right, everyone?
Yes, sir.
Okay. So in this technique, we'll calculate two things. One is term frequency, and another is inverse document frequency. These two things individually will calculate. First thing is term frequency. Okay. So let me just for term frequency. What are the unique words? Again, unique words. Unique words are what, guys? Key is one unique word. Keys is one unit code. Good, coder, and bad. Only like unique words will calculate it. Okay. So for document one, we'll calculate first. Document one. Okay. In document one, is present, guys? Yes or no?
Ye-
Yes, right.
Yeah.
Then one. Is also present, as you can see. One. Good is present. One. Coder is present. One. And bad is not present, right? Okay. Bad is not present. Then we need to calculate the term frequency. So what does the term frequency means, guys? Frequency, anyone? Okay.
Particular
So we'll
higher
tell them.
the particular term getting the higher frequency.
Yes, that's it. That's the thing we are going to calculate. So in document one, guys, how many words are there total? How many tokens?
Four.
4, exactly. So we'll do 1 by 4. Means how many times it is there, that many times by total number of tokens. It will be somewhere around 0.25. And this thing also 1 by 4, 0.25. This is also 1 by 4. Note down, guys, everyone. This thing, note down. TF-ID of note down. I'll give you some examples also. I'll ask you the mathematical expansion, everyone. Okay? 0.25. And this is 1 by 4, 0.25. And this is 0 by 4, which is 0. Okay, understood? Clear, guys? So, okay. This is the term frequency of document 1. Okay, document 1. We have chosen document 1, right? So we'll calculate the same thing for document 2 also. E is good, gooder, bad. Okay. In document 2, we are calculating, and we will calculate the term frequency. Okay. So in document 2, he is present, right?
Yeah.
Yes, it is present. Is present. Good is not present, right? Is it present in document 2?
No, it's not.
Okay. Then we'll give it 0. Then here 1, here 1. The same thing, we are again calculating the term frequency. 1 by 4, 0.25. 1 by 4, 0.25. It will be 0. It will be 0.25. It will be 0.25. Note down, guys, everyone. If you note down, then you will get clear understanding. Okay. So we have calculated the term frequency of document 2 also. Okay. Document 2 also we have calculated. Now the next thing is inverse document frequency we have to calculate. Okay. So for inverse document, like okay, through documents we'll calculate. Here term. This is a little bit different. Again, what are the unit terms? E is there, is there, good is there,
Bad.
coder, and bad. Okay. So here we are calculating document frequency. So how many times it's repeating in both the documents?
Twice.
Twice. So I'll give you here 2. He is how many times it's repeating?
2.
2 times. Again 2. Good. How many times it's repeating?
1.
Okay. Here code also 2 times and one bad is 1 time. Okay. So here we need to calculate this is document frequency. Okay, this is document frequency. Means how many times a word is frequently coming in both the documents, in total number of documents. So we have to calculate the inverse document frequency. Okay, I'm writing short form, guys, for your understanding. In your notes, write full form only. Inverse document frequency. Okay, so inverse document frequency, it's like a formula ln of log of to the base of e with n number of documents by document frequency. Okay, so here log of, see the formula, log of n by document frequency. Log of n by document frequency means n here is 2 total number of documents, and document frequency here for word is how much? Document frequency, guys. You can see the table. Yes, exactly 2. So 2 by 2, 1. Log of 1 is what? Log of 1, guys. Okay, I'll tell you. Log of 1 is 0. Okay, just understand, log of 1 is 0. If you can check in calculator also, we have formulas, right? Log of 1, 0. Okay, everyone must have forgotten it. Okay, so the same thing here. Log of total number of documents is 2 by document frequency. Document frequency of each is 2. Again, cancel 1. Again, it will be 0. Again, log of frequency of 2 by 1. 2 by 1 means log of 2. So what is the log of 2 value?
1.
No, it's not 1. One second, I'll
Is it
check
0?
in calculator.
Is it
It's
0?
not, no, it's not 0. Here we are not using normal log. It is like ln, log of with base of e. Base of e. This is another logarithm. So I guess one second, let me check in calculator. Okay, guys. It will come around 0.603. 0.603. Log of 2 value is 0.603. Okay. Anyone having any doubts? Guys, majority of people are not responding. Only
sir.
Lokesh and Anam are responding. Guys, what about others? Akash Gupta, Aaron Sean, Sahith, Satvik. Respond, guys. Then only I get to understand, right? You are understanding or not. Okay, then. Your log of 2 value will be 0.603. Again, for this thing. For coder, log of 2 by document frequency is 2. Again, log of 1 will be 0. Again here, log of 2 by 1, which is log of 2, which is 0.603. Okay? Noted, guys, everyone till here? Anam, are you noting now?
Yes, sir.
Okay. So, now we are calculating TF-IDF. TF-IDF means TF multiplied by IDF. Okay? For document 1, we will calculate. Okay? So, for document 1, what is the TF value? See here. This is the term frequency of document 1, right? Here we have calculated this thing. These are the values, right? 0.25, 0.25, 0.25, 0.25. This is 0. And inverse document frequency. 0.61. IDF 0.603. He is good. Good. Let me check. Okay, same thing. IDF. Okay. Now we will calculate the TF IDF. Okay. So what is TF IDF? Multiplication of term frequency and inverse document frequency, right? So we'll just multiply these both values. 0.25 into 0 is 0. Here again 0. 0.25 into 603 somewhere goes like 0.8, I guess. 0.8 something. Not 0.8. Let me calculate things. 6250.
0.80.
0.153.
15.
Okay. Here again 0. Here again 0.153. Okay. This is for document 1, guys. Okay. Document 1, we are getting these values. And same for document 2 will do. Okay. If we see term frequency of document 2 is this 0.25, 0.25, 0, 0.25, 0.25. Here again, inverse document frequency will be same for both the documents, every documents. 0, 0, 0.603, 0, 0.60, 603. Something. Again, we'll multiply it. Term frequency into inverse document frequency. Okay. Here it will be 0, again 0, 0 into 0.0, 0.603, 0, 0. At last here will be again 0.153. Okay. These are the term frequency, inverse document frequency of document 1 and document 2. Let's again shuffle it and write. What are the values we got? 0, 0, 0.15. Here actually, I'm sorry. Here 0 will come. I did mistake. Here 0 into 0.603, 0. Guys, got it? Once again, I'll write clearly actually. It's becoming a document. So guys, once tell me, here these are the words. He is good, coder, bad. These are the words like first word, second word, third word, fourth word, and fifth word. Now tell me guys one thing. these words in these documents, how the importance is given. Now, once tell me in document one, what is the importance? He is God, is God, good is God. Now, which words like have given the more importance?
Good and
Good and
bad.
bad.
Hmm. So, like good and bad are the important words, right? So they are given some importance based on the other words, right? So, what is the drawbacks we are like overcoming from the bag of words?
It is giving like importance to particular term. As
Exactly.
it importance to every word.
Hmm. So he is not that since we have taken only two documents, right? With he is got a little bit of sentences. That's why it's given zero, like nearly less importance it has given. So what we are achieving here, importance of words. So what is important of words? Importance of words, guys. Why it really useful? Tell me.
So it can change the meaning here without taking a specific word as
To
important.
different
It may change the meaning of a sentence.
Yeah. Anam, you are telling something?
to differentiate the data.
Yes, differentiate the data also. So if we send these values into our machine learning model, my model can now understand which word is important, right? If my models is like a good word more important, then it will give some importance to it. So good word has some label on it. Like if good word is coming more number of times, it is like some kind of positive sentence, right? If bad word is coming more number of times in the document, then it could be a negative sentence. We can classify the sentences based on these important words. That's why we are giving good word that much importance. Okay, that's why we are giving importance. So if anyone asks you like what is TF-IDF, what it is overcoming from the bag of words, then you need to tell the importance of words. In bag of words, we doesn't assign any importance of words. We give same value for each and every word. But in TF-IDF, we give importance. So let's see this clearly, guys. How many times good and bad are repeated in both the documents?
Once,
Hmm. Good and bad are repeated only one time. How many times like rest of the words are repeated?
twice.
Rest of words twice. So you're understanding if increase in frequency or like increasing in the number of words, if number of words are increasing, then importance is decreasing. Okay, because repeated words doesn't need that much importance because they are repeated means they are getting some kind of multiple values. It doesn't need that much importance when we are converting into numerical values. So if like less repeating words are there means they will be not giving that much priority. That's why we are using this vectorization technique. Here, less frequency words are given more importance. Based on that agenda, this technique came. So in simple words, you can also tell what is TF-IDF means. Means here we assign the importance for lesser frequent words and less importance for more frequent words. Okay, clear guys? As you can see, E is and each and every other word came like zero value, and good and bad came 0.153. It's giving some importance because it's repeating less number of times. Okay, got it, guys?
Yes, sir.
So okay, now I'll give you some like example. You must do the mathematical calculation of it by your own and show me. Okay, you can send in the group also. It's fine. Send the photos in group, the calculations of everything, TF-IDF. So what examples Let me do ChatGPT 1 second. I'll give some examples. Examples of TF-IDF documents. I guess 2 documents will be enough. Yes, given very simple. A little bit more difficult. Okay, guys, take this example. For document 1, which is data science uses Python. Data science uses Python. For document 2, data science uses statistics. Hmm, statistics. Okay, convert them into vectors and give me the values of TF-IDF. I'll send in group also. 1 second. Here, guys, are you having any doubts? Can you do it by your own? Everyone. Anam, Lokesh.
Yes, sir. I'm doing.
Okay. And Lokesh, Sahid.
What I'm doing, sir.
Yes. So I'm giving you like 15 minutes of time. Do it 10 to 15 minutes of time. I'll just come in a while. You guys do and send the photos in group, okay? Whenever you are completed, okay? Okay, guys, I'll just come in a while, okay? I'll take one break. Hello guys. Hello people.
Good afternoon, sir.
Good afternoon. How are you all? So people, what did you do? Hello guys. Hello.
Yes, sir.
Yes. What did you do?
So we learn how to calculate the TF and IDF value.
Oh, okay. Okay guys, tell me. So you learned about TF ideas?
Yes, sir.
Yes. So tell me about TF idea.
So first we learned about bag of words, and then bag of words cannot give importance to particular word or cannot differentiate the data exactly. So we learn how to give importance to a particular word using TF and IDF.
Got it. So the problem with bag of words was what was the problem? So guys, every new thing that comes in any algorithm or any domain is because the previous thing was having some problem, some limitation, some limitation. We jump to newer algorithms or newer architecture to overcome these limitations. Okay, that's how we get new algorithms or new architectures. They are not something out of blue. They are the advancement of the previous architecture of algorithm. Now tell me, what was the limitation of bag of words? Like you said already, but say it in more technical way. If if possible, do, or you can even go with the simple term.
Sir, it cannot analyze the situation, sir.
It
Because
cannot
in a
analyze.
in a single language, a word can have multiple of meanings.
Okay,
So it can't analyze according to the situation, but it predicts and gives the answer.
predicts and use the answer. Okay,
It doesn't give
so
contextual information.
yes, the main thing is context. This is the main thing, context. Unless your model or your Gen AI model, especially, if it doesn't know context, then the output it produces is random. It's random. It's not contextual. It doesn't consider evidence, contextual evidence.
it produces random outputs. And we cannot have this. We cannot have random outputs when you want accuracy and efficiency. Got it? Okay, TF-IDF, the full form. Did you people understand the full form of TF-IDF?
Yes, sir. TF is term frequency and IDF is inverse document frequency.
Term frequency and
Inverse
inverse
frequency.
document frequency. What does this mean?
Term frequency,
What
it's
do yes, Lokesh?
how many possibilities of a single word.
That is
Term frequency.
okay. Inverse document frequency.
It checks the frequency of a word by using a formula like log n by df.
Hmm. Okay,
IDF.
like this is for
How
word.
important?
Yes, Anam.
Sir, inverse document frequency tells about how important the word is across like all the words.
Okay. How important the word is? How is it doing it? Term frequency is yes, guys. Term frequency is
It checks the term frequency of document 1 and document 2.
yes. I mean, what is term frequency?
It checks the
How often?
possibilities of a single word, sir. How many times it
Num
is repeated in
Number of
document of it.
repetitions of a word in a document, right?
Yes, sir.
A document. Document is nothing but a corpus of text. Text. You have a text. This is a document. That's it. There is no advanced reasoning for it or advanced terminologies for it. It's just that here we say document, some other place we say corpus, some other place we just call it text, some other place we call it data. Here we call it document. That's it. So within a document, how many times a word is repeating? Okay, we have the count of that. Then inverse document frequency.
How important the word is.
Like how are you doing that? How important? How are we? See, you know, I know that how important a word is by looking into it. But for a machine to understand, there is math. There is reasoning. How is our machine going to reason?
Like
To
the
check the
number of
unique values, sir.
and the number of by like number of important documents.
What is important documents here?
In clear words, it's like the total documents, and it's divided by the documents containing the words.
Total documents divided by documents having this word.
Words.
Having this word. Okay. So, so if I say if there is a book upon Python, a book upon Python, okay, and you give it to your model, this book, this entire document. Each page can be a document also. Each page can also represent a document. Entire book can be a document. Depends on you, what you want the document to be. Okay. How is it going to find important words? First, it will calculate the times that word is coming in entire all of the documents, right?
So
All of the documents are single document.
single document.
Single document. Okay. If it is taking single document now, Then what's the next process? The next process, how are you going to say, how are you going to find the important words, the keywords of this entire book? Keywords, important words. You calculate, okay, your Python book will have Python so many times. Okay. Let's say you're saying oops. You know oops, right? Oop, not oops, oop. Object-oriented programming. Do you know this, guy?
Yes.
You
Yes,
know it,
sir.
right? And it will come with Python. And it is important, you know it. Your machine needs to know it. So it will calculate the number of times it is repeated. And number of times it is appearing in each of the document. In each of the document. That is, this is term frequency, this is inverse document frequency. Am I right? Or did I make a mistake here? Yes, people? Okay, you also did the math. Good and bad. The rest of the words too. Frequency, importance. Data science uses Python, data science uses. He is good coder, bad coder, okay. What did you take the he is repeating 2 times, then you take the log, okay. It gets 0, 0, good and bad. Okay. So you understand, so did you understand this example?
So we have done sample
Sir, we
example
have
and
done.
You have done?
We have posted
yeah,
the
Can you,
solution
we
in the
have
group, sir.
group, sir. Yeah.
okay. Let me see that. So Anam has shared and I guess Patil Saab is you, Lokesh.
Yes, sir.
Data in document, okay, one. And you're calculating in what? Document one. Okay. For in the document one, how many times it is repeating and the inverse frequency. Is it inverse frequency or term frequency? Term frequency, right? Yes, that's TF, right? Above, Lokesh?
Sir, your voice is not clear, sir.
Yes, sir. First we have calculated TF.
TF, right? Okay.
Yeah.
It looks like IF. Okay, 1 by 0 0.2, 1 by okay, 1 by 5 0.2, good. Python doesn't comes 0, and you're taking log 0 0 0. So the main reason is when you take bag of words, you're calculating only the bag of words, you're calculating only the repetitions. What happens? There are few rare words. Got it? There are few rare words. They might be important. They might be important, but bag of words will consider it not important. For example, see your example. Data science uses Python. Data science uses statistics. Here, data science, it is uses is repeating. So bag of words will think these are the important terms and these things are not important because the frequency of the repetition is rare. It is less. But contextually, if we see, this is more important than use the word uses. Am I right?
Yes, sir.
Right? Now, to even count this rare words importance, the rare word, how many times it is coming, with what it is coming. To do that, to even consider rare words in our calculation, we do TF-IDF. That's the main reason. The limitation is bag of words ignore rare words, even though they are important. But in reality, we cannot do that. The users might be repeating, but it is not as important as Python and statistics. Got it, guys? Got it? I hope you understood. Then you multiply it, yes, and you get the result. Good. Good. And I'm also did the same. Yes, good. Good, guys. Only two people. Okay, no problem. Then two people will only get the performance analysis then. Sure. So today's theory will end it here. We'll go on to practical thing. So yesterday's work, what did I assign you? Two works, right? What was the first work, guys?
One is to implement a program that it should read the PDF.
Yeah.
Extract the
Using PDF plumber.
extract the content of a PDF. Okay, PDF. Using PDF plumber. Using
Yeah.
PDF plumber. Okay. Did you guys do a research instead of PDF plumber? Is there anything which is more efficient? Because I just saw PDF plumber once and I thought, okay, we'll use this, but it might not be the most efficient one. Did you guys do it? You need to do that. One thing cannot be the entire solution, guys. Got it? There are better ways to do a single task. There are multiple ways. In that multiple ways, you must find the efficient one. Right now, our efficiency depends on time. Okay, how fastly it is, how quickly it is happening, and as well as how efficient the output, how accurate the output is, how accurate the output is. But when you actually work in industries, there is something more that comes into picture, and it is one of the topmost. It comes first than this and this. That is cost. Right now, we are not putting any money, so we won't consider this right now. But when you actually work on industry grade products, market based products, actually what companies build, this is the most important thing. Alongside this also is important, but also cost comes into picture. Got it? So there can be multiple ways of doing one thing, but we must find something which satisfies all this: cost efficiency, time efficiency, and accuracy. Also space efficiency. Space efficiency. Space complexity also comes into picture.
The version of PDF plumber.
Mm-hmm.
Are you talking about the better version of PDF plumber?
Yeah, is there any better way of extracting content other than PDF plumber, which produces more accurate result than PDF plumber? See, one way is just reading documents, articles to understand. Other way is experimenting. That you install multiple, what do you say, libraries and test. Experiment. Is PDF plumber giving me the better result? Is something there is PY, PYU. PUDF, I guess. I don't know. I do not remember that. And there is report labs. There is also report labs. report labs is also one of the library. So I'm asking, did you do this? Did you read articles, documentations, or even use ChatGPT? Did you experiment, found any better options than PDF Plumber? Yes, guys? Not that down. That is important when you work in a company. Your boss, your manager might say use this, but if you go do a research, you might find something better and you can propose it. You can propose it. That instead of using this, we can use this and reason. Do the reasoning. So, other thing was a little research or study about research about vectorizing techniques. One of those was one hot encoding, and the other one that you studied today is TF-IDF. Well, there are other ways also. There are other ways to do the same thing. Depends on your problem statement. Depends on your problem statement. Is it a smaller project or do you only get smaller chunks of data? Go with one-hot encoding. Nothing's wrong with one-hot encoding. The only limitation is if number of lines increases, the length of data increases, it becomes inefficient. But if there is smaller data that you are passing, what's wrong with one-hot encoding? If you do not want rare words, go for bag of words then. Bag of words. There is also CBOW. There is something called word to vec. Word to vec. So many things. Did you people research about it? Yes, guys?
Yes, yes, sir.
Yes?
Yes.
Good. Tell me, what did you get to know? Tell me your
Got
insights.
to know about one hot encoding, the word embedding, and
Got it.
engrams, like
Okay, engrams, very good.
the
What
word,
are engrams?
sir,
What is engram?
like it is like a sequence of words where it includes, I guess, trigonometry.
Trigonometry? No, we don't have any trigonometry. The thing is, based on the previous terms, we will decide the next term. The engrams, the previous n words using the previous n words, we predict the next word. Okay? Engram. Okay, try to understand it more. It is important that this is one of the basics of NLP. NLP. Do your research on it, understand the mathematics of it. Why was it proposed? Of course, the simple logic. If I know the context, the previous context, I can definitely predict the next word. But of course, that's not as accurate as we can think because we are human, so we can predict. But a machine, it needs much more context. The school near the what? Now what? The school near the what? The school near the what? If you want to predict, I must have much more information. So how are we going to overcome this? So everything you start from basic and basics will have limitations. To overcome that limitations, we bring new topics, new algorithms, new concepts of mathematics, which will produce new algorithms, new architecture. This will have some limitations again. We will go for new. For example, if you talk about artificial neural networking, okay, this is deep learning. Deep learning. What is the concept of artificial neural networking? Scientists, they saw a human brain, they saw the human brain and thought, I want to replicate it. Because that's how you will be able to create a replica of human. That's what machine learning and AI is. That's what machine learning and AI is. Yes, replicating a human mind. The way we make decisions, the way we understand data, we want machine to do that. So the best thing to do that, replicate human brain. What does human brain have? Nerves, nerves or neurons used for communication, processing, and everything. Main thing is communication and processing of information. Now, when they saw this, they thought, let's make a model of it. They came up with perceptron. Perceptron is one single unit of entire brain called perceptron. It's called perceptron. In our terms, we'll call it neuron. So what happens? If I send information into my neuron in my brain, if I send data, let's say X, it will produce a result Y. What is happening here? What is happening here? How is the decision being made? I can send multiple information again. X1, X2, X3, X4, X5. Yes. And each information will have its own importance. For example, guys, let's say you want to go to a movie and you activated your neuron. You said, I want to go to a movie. First thing you will say, actor, who is the actor, who is the director, actor and actress both, who is the director, who is the music director, how far away, sorry, how far away, the distance, music director, etc. etc. You um, give so many inputs. These are inputs, information. Each information will have its own weightage. For example, if the actor is Prabhas, I will definitely go. My chances are 90%, let's say. So my weight is 0.9 here. Distance, I don't care. Even if it's far away, I will go. So I will put 0.3. That is 30% chance that I will not go to a movie. There is only 30% chance. There's 90% chance that I will go to a movie here. So each information will have its own weightage. And how are we going to produce the result then? So basically, there is a very simple formula or equation for that. That is, looks like, which is equation of line. As simple as this. This thing happens inside this, and then a result is produced. How? How these people analyze it? Of course, they are mathematicians, researchers who spent years and years of their experimenting and got to this result, that you can use this to make decisions based on whatever information you get. Of course, this produces linear outputs because it is the equation of straight line, and a line is linear. To introduce non-linearity, they introduce activation functions. Activation function. So that's deep learning, guys. So what I was saying is, the main thing I wanted to tell you guys is they introduced something called RNN. Okay, there was ANN, artificial neural network. Based on that, so you have multiple perceptrons. Got it? Multiple neurons. You pass information to these neurons, and then you connect these neurons to more neurons. Here you have 4 more neurons in here. You connect all them. You make a fully connected neural network. A fully connected neural network. And then this is connected to, let's say, one more, the final neuron, the output neuron, and produces a result. This becomes artificial neural network, replicating human brain. But the problem was ANN was not of that caliber that can efficiently and accurately do images. So CNN came into picture. In that we had something called kernel filter. You can do your research onto this. What is kernel filter? Basically, these are the filters you apply on your images: sharpness, saturation, hue, etc., etc. That is kernel filter. And but what happened is, this was one particular data goes and the output comes. The problem was sequential data again. sequential data. The limitation of this and this was sequential data. It cannot handle sequential data. That is text, for example, video, for example. Those are sequence. What is a video? Sequence of frames. What is a text? Sequence of characters. Yes, sequence of characters, sequence of words. The problem was this, so introduced RNN, recurrent neural network. The problem with RNN was it would crash for longer data. It would crash. There is a reason why it crashes. It crashes, and the entire thing, what do you say? It produces a result. Even though crashes, it produces a result, but the result is again not accurate. So what did they introduce? LSTM. Gates came into picture here. Gates, like human brain, we had forget, like we humans forget things. We introduced a forget mechanism. Important, what we should remember, a remember mechanism. What should we produce the output, input, etc., etc. We had multiple mechanisms. Gates we had forget gate, input gate, and output gate. That came with LSTM. LSTM had one more, what do you say, limitation, that is bigger context, larger context. If there is larger context, then what? Then came transformers. Introduced in 2014 by Ashish Vaswani and his team, a research paper called Attention is all you need. Attention is all you need came into picture, and attention mechanism was brought into picture. Self-attention, self-attention, self-attention. Using this, they produced ChatGPT, they produced Claude, they produced Perplexity, they produced all the generative AI models you know right now. Transformers. Now for transformers, there is another thing, the advancement Magma in 2025. So each limitation comes, and for those limitations, we introduce new things. That's why I wanted to say to you guys. For just sequential data, we have RNN, LSTM, transformers, and then Magma. Right now, no one, it is not as popular as transformers, but it has come into the picture in 2025. Yeah. So that's how you need to do research. If you're studying RNN, okay, you spend 2 days, 3 days, 2 to 3 days. Then what happened with RNN? Has some limitations, get into LSTM, understanding mathematics, and it will be fun. That way of learning is fun. Sure. Now, I want to see your codes. Who will show the code first? I want everyone's, of
If you
course.
don't mind, can you explain the previous concept once again, sir? Due to
Which
some
one?
issues, I have logged off, and again I logged in 2 minutes back.
Okay, I was not explaining anything. Like I was just giving extra knowledge for you people about deep learning, artificial neural networks. That's it. Nothing more. You can also watch it in the recording. We will send it to you. Did you get yesterday's and day before yesterday? Did you get it?
Yes, sir.
You'll get this as well. So I was just sharing extra knowledge. That's it. It was not related to our internship. I'm just sharing extra knowledge about overall overview of ANN, CNN, RNN, LSTM, transformers, and now Magma. So we can look into it. So guys, your quotes. I want to see your quotes. I want to see how efficiently you have built your extraction mechanism and how much you understand each line of code. Each line of code. Whoever says you need not learn each line of code is a fool again. You need to understand what you're doing. Okay. Colleges usually say this. I've heard it from the higher ups of colleges that we cannot explain entire line of code because no one knows it. That's crap. So yes, quotes. Who is going to present first? Let me unshare the screen. How do I do this? Teams. Yes. Come on, guys. Let's see your code today. Camera. Yes, guys. Who is going to share? Take the opportunity. See, I don't want the best code again. I'm just trying to build that environment for you guys that you stay serious and not asking you to be a professional again. It's just that I want that environment to be here. Or else, if you are my student, for example, normal class, then I would not pressurize you people like this. It's an interview, so I'm doing it that way. So do not worry. I won't judge you if it is not as efficient as I think it is. You can share your screen, definitely. We'll look into it. We can get into the improvements. Today only 4 people joined. Sad. Don't know why people do not like this free stuff. No one, no one wrote the code. Asked you to write a program, right? Yes, Anam, did you write it?
Yes, sir, I wrote it. I'm
Then
trying to
share
put
it.
laptop and then
So you're not on your laptop right now.
no, I'm not on my laptop.
Okay.
Just
Lokesh?
Sir, I have did, but I have used AI. Right.
Okay, no
So
problem. That's what I said yesterday. If you at all you're using AI, understand each line of code. That's what I told yesterday. I understand what you are doing. As long as you understand and do it, it's not a problem. But try to do it on your own in future. In future, right now you're learning. You're in your learning stage. You can use your AI. You can use other sources. You can use other codes, GitHub codes. Again, the only thing is learn from it. So you can share your screen. Make me understand your code.
just a minute.
Okay. Others, Sadia and Sony. Sadia and Sony, are you in the class?
Yes, sir.
Yes. Did you write the code?
I'm using phone. I can share my document.
Sorry, I didn't get you.
Using phone, sir.
You're on phone.
Yes, sir.
Can you get onto your laptop?
Yes.
Can you get onto your laptop and then show me your code?
Okay. Okay.
Please do that. And Sadia, Sadia, no response from Sadia, though her mic is on. Though her mic is on. Leaving, she left the meeting. Maybe she's facing some problem, no problem. So, Lokesh, Anam, Sony.
Sir, is it fine if I put it on the picture on the group and then explain it?
Okay, that's fine if it is, but I also need to see the execution, right? Is there a problem like drawing from the laptop?
Yes, sir, I'm facing a problem.
Okay, so okay, we'll check the execution later. Let's understand the code for now. Then I need to log in to WhatsApp. What I need? तुम्हारा है नहीं? कब है तुम्हारा रिव्यू? धूप बहुत है, क्या बाकी है? Till does it others locations only? चल रहा है, ऑलमोस्ट हो गया ना, 2-3 और है कल। अच्छा हाँ, ये कोड देख लेते हैं, खत्म कर देते हैं। Okay, Anam, I will share my screen and then we can discuss your code. Let me download your image first. It is visible, right, guys? It is visible, right? Yes, people? So from Flask, import Flask and request. Got it. PDF plumber. So explain, Anna.
Yes, sir. So it's like we are using the import Flask, the first thing which is used to create the web application, and then we are requesting like accessing the data from the file. Suppose it's like a file, and then we are requesting the file to access it, and then we are using the import PDF plumber. It is a library to extract the text from the PDF files. Like we upload our resume in a PDF file, so to extract the data from that we use the import PDF plumber, which is used to extract. It's a library in Python which is used to open the file or extract any text data from the PDF file. And
Got
then
it.
we have this creative creative Flask application object in that app is equal to Flask. That is the name which tells the where the application is actually there. I mean the name of the, which tells the Flask where the app is located exactly. And then we are using at the rate app.root, which is like very important, which is like a method where we used to like root the.
Yes. Calm down, no problem.
Yeah,
No
like
problem. You can go slow.
we use this app.root to direct. It is a method which used to upload a PDF. When we have a PDF file of a resume, we use this thing to upload our resume in that, and then it will store inside a variable using a PDF plumber and extract the data. Again, it's again the PDF plumber thing which will extract from it. And then we have df upload, and then which defines the function, and with the help of upload it is accessed. Now we can retrieve our file, and we can actually upload the file or retrieve the data from the file.
Okay.
I hope I am
So
clear.
explain me the function, each line, what is happening with, what is happening with per, and what is happening text plus equals to.
Okay.
Yes, why did we define text as empty string? And why did we then use with and all those things? Let me know.
Okay, sir. Like the text we have kept it empty because it is like it is an empty string to store the extracted file. I mean, when
Got it.
the data is extracted, we store that in that. It is like it is stored in that empty thing.
Okay. Okay. So initially we have no text, so we will have an empty string.
Yeah, yeah.
Okay. Next, the line 12.
And then it's like pdf.plumber open file. So it will open the uploaded PDF. The PDF is being opened using PDF plumber. And
Okay.
according to the pages, now it will have pages, or suppose a single page. It will open each page of the PDF through loops.
Got it.
And then text plus is equal to page.extract is extract. The text will extract from the page to page wise, and if there is no text found, then it will be again added into like errors or anything like that.
No, no. If there
Okay,
is
okay.
no text, what did you
Huh.
define there? Or
Or it will be like empty.
yes. So if you
Okay.
have text, you have extracted some text, then
Mm,
this will
yeah,
be added into text. If you
yeah,
do not have any text in the page, then empty string is returned. That will be added to your text variable.
yeah. Okay.
Okay. And then you return the text variable. Got
Yeah,
it?
it returned in HTTP, which is Hypertext Transfer Protocol. And then
No,
yeah,
I
again
didn't get it. I didn't get it.
the
What
text.
happens?
So what happens is the return text
Got
sends
it.
the extracted text as a HTTP, which is like Hypertext Transfer Protocol. Like it's like a communication between the client and the server.
Got it. To whom are we sending this text?
We are sending to whom?
Yes. Or where are we
Uh,
sending this text? You said we are using HTTP to transfer or to send this particular text we have extracted to
hmm,
someone or something. Where it is going?
hmm. We are getting it.
Okay, we are getting it. So we got it through this code. I understand that. We are
Yeah,
returning, and you said we
yeah.
have used HTTP. So HTTP is a protocol, is set of
Hmm,
rules.
hmm,
Protocol means set of rules, which is used
hmm,
to transfer data
hmm.
from document to document, from web page to web page.
Yeah.
So where are you sending this text?
To the main method.
Where is the main method?
Sorry, sir, I don't know from here.
Okay, you are sending this to slash upload. You have
Yeah.
defined something, a
Hmm,
web page, which is
hmm,
upload, if I am not wrong. And
hmm,
you have also defined the method post. Basically, you're
hmm.
sending the data.
Yeah. Yeah.
Whenever you send data, you use post. Got it?
Hmm, hmm. Yeah. Yeah.
And that is going into one of your HTML files,
Hmm, hmm,
which has this slash upload, what do you say, name in it, not name,
hmm.
what do I call it? Identifier in it. and
Mhm.
there it goes. There this text goes and it is shown to the user.
Okay.
So to send this text from your backend, whatever you have done here, to your front end, that is HTML file, you
Hmm.
have used HTTP, and in HTTP, the method you have used is post.
Yeah.
Got it? One more
Yes.
question. In line 13, for page in PDF.pages, can I use anything other than page? Like for page, there is for page, right?
Mm-hmm.
Can I use any other name there, or should I only use page, the variable name page?
No, sir. I have no idea about this.
So it is
I
like
just get
the
yes.
it is like the basic syntax of Python.
Hmm.
So
Okay.
how for loop works? There are two ways of for loop works. For
Yeah.
loop works in Python. Number one, for some variable name in something.
Mm-hmm.
Okay. The
Yeah.
variable name can be anything. I can write for I in PDF.pages. I can write for X in PDF.pages. I can write for page
Mm.
in PDF.pages. Like I told, naming convention is necessary whenever
Okay.
you're
You are,
coding
instead of for page, we can use a variable name.
any variable, I,
Ah,
X, T, U, V,
yeah.
W, whatever it is, or you can
Okay.
use page. Why did you use pages? Why, wherever you got this code from, why the page actually we took the variable name as pages, the naming convention. Like I told you
Mm.
yesterday, that whenever you are coding, whatever you name, whether be a variable, whether be a file name, it should be meaningful.
Yeah.
Okay. So whatever you're doing, if you can even write for I in PDF.pages. Then
Yeah.
you can write textplex equals I dot extract text.
Yes. Yes.
Got it? That's how for loop works.
Yeah.
That's one way. The other way
Mm.
of running a for loop is within a range of numbers. Got it? For I
Mm.
in range of 10. If I write for I
Mm.
in, let me share my screen. Hmm, I can remove this. So for I in range, this is a function range of 10 if I write. Then if I print I, if I print I, it will print, it will start from 0. Got it? It will start from 0. 1, 2, 3, 4, 5, 6, 7, 8, 9. It will not go to 10, it will go till 9. The 10 is excluded in the range function. Starts from 0, ends at 9. You can even mention range of 1 to 10. What happens? 1, 2, 3, 4, 5, 6, 7, 8, 9. That's it. 10 is excluded in range function. That's
How
how
about
range works.
zeros? It won't
Hmm?
count from zero.
No, you have explicitly mentioned that the start value is 1, the end
Oh,
value is 10, but it
okay.
will start -1, end -1. That is 9. You have one more thing, step in range. A range of 1, comma 10, comma 2. If I write it like this, usually step is 1. Step means how much you are jumping from the current number to the next number. If it is 1, that is by default it is 1, it will go 1, 2, 3, 4. Okay, linearly. If I mention 2, it will go 1, then it jumps 2 steps, 3, then 2 steps, 6, 4, 5, sorry, 5, then 2 steps, 8, then 2 steps. What is 10? But we have mentioned the end is 10, the end is 10, and my range function only calculates until n minus 1. So I'm jumping 2 steps from here, that is 10, it won't be shown. So it will end at 1, 3, 5, 8. Got it, people?
Yes, sir.
This is range function. So two ways of using for loop, within a range or within something. It can be a list. It can be a list of something. Okay. It can be a list of something. It can be like you did right now, pages. Yes, file dot pages. What are these pages? We need to see it again. How is the pages being written? Got it? This is here. You need to check. You're doing per you're doing per page in file dot pages. You're definitely doing this. But what exactly this method? This is a method. Pages dot pages is a method which is being run upon your file, which is being applied upon your file. But what it is returning? Every functions return something. Either it returns something or processes something internally. So it definitely is returning, because if it doesn't return, page will be null. Page will be null, null, none. If it is not returning anything, if it is returning anything, then it goes into pages. The first thing it returns goes into pages. That first page is analyzed, code is extracted and put in your text variable. The not code, sorry, the document, the whatever text you have. Then it goes for the second thing. First page is done. Now goes for second page. Now goes for third page. Whatever how many number of pages you have. So you need to see what this thing is returning. You can either go into documentation of PDF Plumber to understand that. You can either experiment by just writing file dot pages. If you just write it in your code, and let's say file dot pages, you put it. I don't know if it will print.
So let's
Put
put it one. Like file dot pages one.
pages
So
one.
it
I didn't understand.
first page.
Okay, I don't know. Is this how this function works?
I
If
didn't
I
get
put one, will it only give me first thing, the
that is
first
what I'm
page?
asking.
No, it depends on how the developer of this plumber, PDF plumber, how did he create that function? It depends on that person. Did he mention any explicit way that if I put one, it will give me the first page, two, if it will give me the second page? We don't know that.
If
We should see the
zero
documentation.
or if it is not mentioned,
I didn't understand.
if it is zero or if it is not mentioned, do we get all the pages or
To read the documentation, or you can experiment again. There are two things, but better way is read the documentation if you have such doubts. That's a valid doubt. That's a very good doubt. How this function works. If I give one, will it work? That's a good doubt. If you right now we know that if I do not give anything, it is retaining pages, all the pages. Maybe it can be in a list. Doesn't in a list, in an array. Maybe it can be in a tuple. In a tuple. Now we must see how it is happening. We will see it definitely tomorrow. We'll analyze each and everything. That's how you what do you say, work with code. When you're using this thing, this method, I need to understand everything about this method. That's how a coder brain works. You need to know whatever you are using. Just I have used, okay, I have got the output, so that's what it does. No, that can be, there can be more to that method that the programmer of this method might have written. So okay,
but I'm assuming if it doesn't mention range and if I like add PDF dot pages zero, will it give me the first page
that's what
if
I'm
we are going
saying.
from
See,
those ones?
PDF dot pages. You do this. This
Yeah.
is a method comes from PDF Plumber. Got it?
Yeah.
This method, some coder, some programmer, he created. Okay, he can create it in any way possible. There is first thing, that is, you do not mention anything. See, define. If I define pages, for example, and if I put it like this, and some process happens, and at last I return something. Got it? If I return something, and if I call this function, inside this, I have not mentioned, remember this, parameters. Parameters.
So are you saying something?
Yes, I am. Is it not
No,
visible?
not able to.
Yeah. It is visible here to me because I'm on a different device. I'm writing on a different device. Maybe you might have some network issue. Or let me unshare my screen. Let's see if that works. Did the screen share stop? Did it stop?
Yes, sir.
Now I'm sharing my screen again. Are you able to
Yeah.
see my screen?
Yes, sir.
Whatever I've written.
Yeah.
So I've defined a function called pages. Let's say I am PDF Plumbers programmer. I have programmed this and I have defined the method. Okay, I have defined the method. I have defined, I have written all the things it needs to do, and at last it returns something. I'm calling it somewhere. I'm calling it this function somewhere. Yes, you define a function, you call it. Now see, inside this, you have not mentioned parameters. For example, if I am doing define sum. If I mention a comma b, that means these are my parameters that are needed to be passed definitely whenever I'm calling it. If I write sum, just sum, and let's say what is return a plus b. If I just do sum and do not mention anything inside, it will give me an error. That is, a is not defined, b is not defined. It will give me that error. Now, if I define it, if I define 2 comma 3, then it will return me the sum of 2 comma 3. That is fine. That's how parameters work.
Okay.
Right now, we are not passing any parameters in pdf.pages. That
Yeah.
means the yes.
Yes, sir. It is clear now. I understood. It's we didn't
Clear it,
define
right?
that.
I agree. It's not a code, so we don't know how this thing work.
Yeah.
Maybe there is a way that if I mention one, it might work. There is something called coarg, guys. Coarg, arg, okay, arguments that if I put here, if I put star r, if I do this, then I can put any number of parameters. If whenever I'm calling pages, whenever I'm calling pages, either it can be empty, either it can pass zero. I can pass 0 comma 1, 0 comma 2, or I can pass pages of 10 comma 2, 10 comma 21, let's say. That depends on how I am writing this code, how I have defined this pages function. So PDF Plumber, for that you need to analyze the PDF Plumber documentation. You need to see how that is working, how this particular method is working. Got it, guys? Was it clear?
Yes. Yes, sir.
Now, Lokesh,
Sir,
so your code will
I'm
will look
sharing.
into your code. Yes, Lokesh.
Yes, sir, I'm here. I'm yes, sir.
So you're going to show your code, right?
Yes, sir, I'm sharing.
Good.
It asking me privacy permission. Can I exit and again log into the meeting?
Okay, definitely. So Anam, there is one more thing. You didn't define your main page. That is,
Hmm.
whenever user enters your Flash application, there should be a route. There should be a route to your base path.
Okay.
So define home or index, whatever you call it. I write define home, and it should read render template. There is a function in class which is render template.
Yeah.
Render template of, let's say, index.html. So whenever user enters your class, they will see this. Okay,
Yeah.
you will see the index.html. Do that and also create all the pages
Hmm.
and show me the extraction tomorrow. Got it? Morning
Okay. But still,
with
I,
UI.
yeah, sir. But still, I need your help. I'm not good at this.
Okay, no problem. You can definitely use AI. That's what I'm saying. You use AI, understand each
Hmm.
line of.
Yes. Yes. Sir, I have to go to college. Can I leave?
Yeah, yeah, you can.
Okay.
Okay, can I
Thank you.
start?
Yes. Lokesh. Hmm.
So this is my code, sir. I have used AI to build it.
Got it? Read PDF logic, text content PDF. And extracting the page. If page text, then you are adding return text content extension. Okay, so no readable text found in PDF. Got it? That's similar to what Anam did. Now, index. What are you showing in index? Extracted data. If request method equals post, file is equals to request dot files dot get files. If file and file name dot ends with PDF, file path is equals to os dot path dot join upload. Okay, you're trying to upload it, save it, extracted data, you extract the data and remove the file after you read it, and then you render the template and the template string you're doing. Okay, once scroll down, and then you are showing the extracted content. Got
Yes,
it.
sir.
Did you
Can
understand
I
the code,
execute it,
each
sir?
line of code?
Not each line, but I have understand the concepts in the code, sir.
Okay,
Meaning
concept is
by
okay, but you must understand how each functions. See, like for example, OS. What is OS? What is the OS
the
library?
OS it checks whether give- uh, the file
Yeah,
which
no
are
problem.
uploading is will be existing in our operating system or not, sir.
No, OS is a library that is used to work with your file directories. File directories within your system. Okay, within your system, you have multiple files. You have document, you have desktop, you have no, sorry, directories. Multiple directories you have. That is desktop, documents, project. Here, project is one of the directory. In the directory, you have upload directory. In that upload directory, you might have the PDF files. App.py is one of the file. So to work around with these things, you use OS. That's how you need to learn these things. Then what is you mentioned methods is equals to get post. What is exactly get? What is
Yeah,
exactly post?
the method get and post means in when I'm trying to end,
Hmm. No problem. Take your time.
that means when I try to upload my the word get the word get says that I'm going to upload my file in the website, sir.
Okay.
So that the post says that the the file will be reading by the OS after
Okay.
uploading.
No, that's not it. You need to learn more about it. And okay, understand this code. It is good. It is extracting. I can say that. But the thing is, you understand the code, even understand this render template string, how it is working. How are we passing comma data is equals to extracted data, where it is going. So today work on that. Got it?
Okay, sir. Can I show the execution part, sir?
Execution we can see tomorrow. I know this will execute. It will execute. We will see it tomorrow. So right now you understand the code. That's the main thing.
Okay, sir.
Execution is next. Understand each code, each library you are using. What is try, what is accept, and what all these things are. File.save we are doing, request.file.get we are doing, voice.remove we are doing, render template string we are doing, and so many things you are doing in this entire how many? Almost 100 lines of code. Understand the 100 lines of code. It's not a big task. Got it?
Okay, okay, sir.
Okay. Thank you, Lokesh.
Okay, thank you, sir.
Thank you.